Okay, everybody, welcome to Pre-Calculus, Chapter 14 on Trigonometric Identities. Why are we starting at 14.3? Because that is where we're starting. You don't have a Chapter 14 in your book. This is, again, me piecing together from other books, lessons that I have done. But we're going to do a whole unit on just trigonometric identities, and it'll be fun. Mr. Belk and I are going to be kind of tag teaming these videos back and forth. At any time, you are allowed to pause this video and copy what you see. And by the way, I'm going to already have some pre-made sheets here, so just to make the video go a little bit quicker. All right, so first things first, what is a trigonometric identity? Things that you'll have to memorize. You've actually seen an identity before. It is something that is equivalent to the trig functions that you've already learned. For example, tan. Tan is equivalent to sine over cosine. So the tan of 30 degrees would be the same as if you did the sine of 30 degrees divided by the cosine of 30 degrees. Okay, it's what we call a trigonometric identity. Cotangent would be cosine over sine. Very easy. All right. Then we've got the reciprocal identities. You've actually already been introduced to these too, and you should know these. The reciprocal of sine is 1 over cosecant. The reciprocal of cosine is 1 over secant. The reciprocal to tan is 1 over cotangent. And then cosecants, it can be written as 1 over sine. Secant can be written as 1 over cosine. Cotangent can be written as 1 over tan. But there's these new ones that you haven't seen before. They're called Pythagorean identities, based off of good old Mr. Pythagoras. This first one is my ultimate favorite one. And if you've seen my board in my room, this is a great promposal. If you were to ask someone to prom, you would say, if you were a sine squared and I was a cosine squared, together we make one. Prom? No, just kidding. What is sine squared, by the way? Just so you know, this is a unique way that they're writing sine squared. Why aren't they putting it on the outside? They want you to recognize that this is actually the same as sine squared theta is sine theta, the whole thing squared. Okay? If they had just put the 2 on the outside, it would look like theta's being squared. So instead of writing all these parentheses, they bring the squared next to the sine part. But that's what it means. It's the whole thing, the sine of theta, and then you square it, even though the squared looks like it's squaring sine. You can't just square an operation. So that's your first identity. Sine squared plus cosine squared equals 1. By the way, you could also, from this, derive the following identities. Sine squared theta equals 1 minus cosine squared theta. What did I do there? I just subtracted this over. Okay? I just subtracted it over. Or I could have left cosine squared and subtracted sine squared over. So let's see. Cosine squared equals 1 minus sine squared theta. So those also can be derived from that identity. Know this. Kind of figure this out in your head. Another Pythagorean identity, tan squared theta plus 1 equals secant squared theta. And then you could actually solve this for tan squared and subtract the 1 over. And then last but not least, cotangent squared theta plus 1 equals cosecant squared theta. If you haven't already, pause this, write all these down. You're going to need to memorize them. It's going to be great. All right, now, before we move on, we need to recall our fraction rules. This is what is the biggest hurdle to get over in this section. Do you know how to add a fraction? Do you know how to combine things into one fraction? So, for example, if you see this, do you know what to do? And I'm sure you're all saying, oh yeah, I know what to do, okay? You find a common denominator, which in this case would be xy. And then really, there's a trick. If you don't know this trick, you should know it. But you can just crisscross 2 times y, put it up here, and then put the sign right there in the middle, plus x times 3, 3x. And now you've made these two separate fractions into one fraction. That's our goal. We're going to try to write everything in one fraction or a reduced fraction. If I have x squared over x, I know this seems ridiculous, but what does that mean? That means x. That's x. Can you do this? Can you cancel those out? No. So you're not going to be able to do it in the homework. And then if you have 3 over x squared plus 1, okay, you'd be like, oh, find a common denominator to make this one fraction. This would be x squared over x squared. So anytime you're adding 1, it's whatever the denominator is over here over itself. And then you can just make this 3 plus x squared over x squared, okay? These are all just simplifying fractions. You should just know this from 7th grade. All right, last and final thing right here before we do 2 examples, steps to solving or simplifying trig identities. First thing we're going to do is convert everything to sine or cosine. Pretty much every time you convert to sine and cosine. Second thing you're going to do is you're going to find a common denominator. You're going to try to create one fraction. It's going to be maybe a complex fraction, like a fraction over a fraction. I still want it to be one fraction. One fraction is your goal. At the very end, you change it back to an original form, which we'll talk about this last step here. Change it back at the end. All right. So let's practice our first example. We're going to simplify cosecant squared theta minus cotangent squared theta over cosine. So step number 1, you're going to want to convert everything to sines and cosines. So how could I rewrite cosecant squared theta? Well, if I'm looking at my little chart here and I see for cosecants, right here, cosecant is actually 1 over sine. If it's cosecant squared, it would be 1 over sine squared. So that's actually what I'm going to do right here. I'm going to replace what I just boxed in blue with 1 over sine squared theta. Remember, I'm trying to rewrite everything in terms of sines and cosines. Okay, now let's take cotangent squared theta. Well, cotangent, should I write 1 over tan? I mean, it's right there, cotangent 1 over tan. I would say no. Again, I want to convert everything to sines and cosines, so look up here. Cosine over sine is what cotangent is. So I'm going to rewrite this as cosine squared, I squared because it's squared, over sine squared theta. Now, what do I do with this cosine theta on the bottom? You're just going to leave it. You're just going to put it right here. Since it's already a cosine, you're going to keep it as cosine theta. So all I've done is replaced cosecant squared with 1 over sine squared, cotangent squared with cosine squared over sine squared, and cosine theta, I leave it. Okay, now here's what I want you to do. You got to make this thing, looks ugly right now, one fraction. So you start with the top. Let me cover this part right here. You're going to make that one fraction. 1 over sine squared minus cosine squared over sine squared. Well, since they have the same denominator, that's pretty easy. If they have the same denominator, you keep the denominator in fraction rules, and you just combine your tops. 1 minus cosine squared theta. Right? That's fraction rule 101. If you have 1 over y minus x over y, that would just be 1 minus x over y. Just combine the top. The bottom stays cosine theta. We're getting there. We're getting there. All right, now I have 1 minus cosine squared. I feel like I've written that before. Let's just take a look. Usually when I look at squareds, if it's a sine squared and a cosine squared or a 1, usually they're within this Pythagorean identity. Look at that right there. 1 minus cosine squared. It would be the same as sine squared. That right there, 1 minus cosine squared, is the same as sine squared. So what I'm going to do, let me just use a highlighter for you. I'm literally going to replace 1 minus cosine squared. And instead of that, I'm going to write sine squared. Well, what's it over? It's over sine squared. And what's that whole thing over? Cosine squared. I should probably thicken that up so you know that it's really a fraction over another fraction part. Well, this gets even better. Look at this. Sine squared over sine squared is 1 over cosine theta. And look at that. We're almost done. And this is what I mean by step 3, change it back at the end. 1 over cosine. What is 1 over cosine? What is 1 over cosine? Oh, it's secant. So you're telling me, Miss Aceta, that that thing right there is the same as secant? Yep. Now, why is this so cool? So next year in calculus, you get to take what are called derivatives and integrals. And you would not want to take a derivative of that, kids. That is messy. It is ugly. It uses a lot of work. Promise you. You'd have to do what's called this chain rule with a product rule, with a quotient rule. It's nasty. But taking the derivative of this, really easy. So simple. It's like, actually, I can't remember it right now. Secant, maybe secant squared x, something like that. It's pretty simple. So that's why we do this. All right, one more. And this, I will admit, is probably the hardest one. If you can do this and follow me, you'll be good. All right, so let's try this out. Again, here's what I usually do. First thing you should be doing on all these, convert everything to sines and cosines. So let's see. Tan squared theta. Tan, in terms of sines and cosine, again, looking at my little sheet here, tan is sine over cosine. Since it's squared, I'm going to write sine squared over cosine squared. Okay. Then cosecant squared, right here. Cosecant squared, what would that be? 1 over sine. Since it's squared, I'm going to write 1 over sine squared. And these are next to each other, which means multiplication, so I'm just going to put a little multiplication sign right there. All right. Now, minus 1. I'll leave it as minus 1 over secant squared. Secant squared is equivalent to 1 over cosine squared. Okay, now let's see if we can clean this up. Two fractions that you're multiplying together, you are allowed to cross cancel. If not, you'd have to multiply across. But this can cancel with that. So the one fraction you'd be left with right here is 1 over cosine squared theta. Then you still have minus 1, and it's still over 1 over cosine squared theta. Am I allowed to cancel those out right now? No, you cannot. That was like I showed you in the beginning on your fraction rules. You can't just cancel them out, okay? You have to combine this to be one fraction right now. So this part right up here needs to become one fraction. So what am I going to do? Well, I'm going to get that 1. Right now it has a denominator of 1. I want it to have a cosine squared denominator. So how do I do that? It's very simple. 1 is equivalent to anything divided by itself. So let's just write cosine squared divided by cosine squared. So your new top would look like this. 1 over cosine squared theta minus cosine squared theta over cosine squared. Doesn't that make 1? The same thing. 1 is the same as cosine squared over cosine. It's the same as sine squared over sine squared, but why would I do that? I need a denominator of cosine squared. Okay, now it looks like we're getting messy before we get simpler, but we're not. Bear with me. So now I'm just going to rewrite my bottom. What would this top become now? Again, just kind of ignore this right now. They both have the same denominator. You can just write the top and add them or subtract them together. So my new top would be 1 minus cosine squared theta over cosine squared. Just put it over one of these. Just combine that part right there. And it's still over 1 minus cosine squared theta. 1 over, excuse me, cosine squared theta. Now we've talked about this in the last one. Look for these. If ones and cosine squareds and sine squareds are together, it's probably a Pythagorean. 1 minus cosine squared is equivalent to sine squared. So I am going to replace this right here with sine squared. So this would be equal to sine squared theta, that's what the orange is. It's over cosine squared. Move this down, which is still over, here's that complex fraction part. Now, what do you do when you divide two fractions together? Same, change, flip. Sine squared theta over cosine squared theta times cosine squared theta over 1. Same, change, flip. And look what happens. These cancel. And what are you left with? Just sine squared theta. So you're telling me this thing right here is equivalent to sine squared theta? Oh yeah. So you are going to try worksheet 14.3. Just do 11 through 19. It's going to be hard. You're not going to like it. Tomorrow, you will like it. Tomorrow's lesson, they will actually tell you the answers and you'll have to verify them. But try them out. Enjoy. It's fun. Bye.